So hi, my name is Jason Merlo. I'm a PhD student from Michigan State University in the Distributed Electromagnetics Theory and Application Research Group, or DELTA, and I'll be discussing some of the work we've been doing on a distributed network radio framework. So just to kind of give an idea of what is the DELTA framework, what we've been calling it, our tagline kind of says it all. It's a collection of software tools and libraries which enable simple configuration and deployment for short-lived distributed radio networks on distributed compute nodes, designed to enable rapid iteration. So really helpful for research and development applications. So the goals of this framework were to enable scalable deployments for tens to hundreds of radio devices. So we want to be able to easily deploy that from a centralized location, like a developer's laptop, and be able to deploy that over bandwidth constrained links. So we want an efficient deployment process that only transfers the files that have changed. And of course, we also want to be able to deploy this on resource constrained devices. So we don't want to be recompiling everything. So we want to preserve build caches and not overwrite that every time as well. We want to be able to easily monitor this from a single location, from a control node. Need not necessarily be the developer's laptop, but is often the case. And then the other major goal is that we want a scalable software interface. We want to still be able to maintain using GNU Radio Companion because it's simple and easy to use, but we want to be able to make this scalable without having to change and copy and paste a whole bunch of parallel processing blocks for every node that we want to add in this. So we've been working on some blocks to make it scalable there as well. So the components of the Delta framework, we have the Delta project tool, DA Pro tool, and it's modeled after the GR mod tool. So we use that for creating, modifying, and deploying the framework software. We have a couple of GNU Radio packages. We have the GR Delta utils and GR Delta coordination. The utils are the block. The coordination aspect is for coordinating the time, frequency, and phase of the distributed radio network. And finally, we have the Delta Python package, which is kind of the framework for the GR Delta coordination package, or the underlying software for that. And so today we have the DA Pro tool published, and it can be certainly run without any of the additional packages, but we are planning to release the Delta utils in the near future, and then the coordination and Delta Python package at some point in the future. So just to give a quick example of how this might work, say we wanted to create a distributed network spectrum monitoring application. So in this case, we have 3 hosts, each running, and we want to have a spectrum monitor controller running on one of those hosts. Each of them is connected to USRP. We want to monitor and control that from a dev laptop. So we'd run DA Pro Tool new proj, the spectrum monitor. It's going to create a folder that looks folder structure similar to this. In the config file, we'll have hosts, and that's where the IP addresses of the hosts and what scripts want to be launched on each node, and which radio resources are connected to each node live. We have the libraries, so where those files on our laptop are, and folders to exclude and installation commands, how we want to install that, and then some of the radio resources. So we'll run, to create the controllers, we can run add monitor node, and that'll create the controller there. We have templates to generate the arguments, that's the Mako file, and then the GRC file. Similarly, we can create the monitor tool. Say we fill those out, we want to deploy those. The deploy tool will run rsync, build that, and then run it. And so we have a quick demo here. We have the 3 embedded computers connected to B205 devices. And so if this will play, yeah, there we go. We just run deploy here. It's going to synchronize all the files, build on each one of the devices, the second step. And then the third step is going to launch over SSH all of the scripts. So we're running no GUI on each one of the USRP or node interfaces. Then we're running the spectrum monitor in a centralized location. So this is just the 2.4 gig Wi-Fi spectrum centered around channels 1, 6, and 11. And then, yeah, so after this runs, we can close it out and check the log files. There's different log files for the deployments to make sure the deployment's processed correctly, and then finally, also just log files for the running of the code. So yeah, thank you for your attention. And if you want to see any further details, the wiki at this link has more details and the source code that you can download for this as well.